All right, today we're diving into a really provocative new idea. It asks a pretty fundamental question. What if the huge, dark emptiness between the stars isn't actually empty at all? We all tend to picture the space between stars as this cold, dead, empty vacuum. But what if we've got it all wrong? What if the interstellar medium is actually, well, teeming with a kind of life we've never even dreamed of? So yeah, let's just get right into it. The whole idea kicks off with a pretty wild suggestion that the space between stars might be home to these enormous living carpets made of microbes, just kind of drifting through the galaxy. I know, it sounds like something straight out of sci-fi, but this is a serious proposal, and it's got a name. It's called the dark biofilm hypothesis. So let's break down what that actually means. Okay, so the crucial part here is we're not just talking about single cells floating around aimlessly. Nope. This theory is all about organized colonies, biofilms, that are packed with protective pigments, kind of like melanin. The idea is that they exist in the interstellar medium, which is that super thin mix of gas and dust between stars, and they actively travel along the galaxy's magnetic field lines, almost like they're cosmic highways. So these theoretical structures would have a few key things that make them really unique. They're microbial collectives, right? And they use those pigments to shield themselves from all that deadly cosmic radiation. They're mobile, not just passive dust. And here's the kicker. They would be absolutely enormous. Large enough that their shadows and the effects they have on light could actually be detectable from way back here on Earth. And look, this concept has real roots in actual science. We've seen microbes that can survive the crazy harshness of space. Just recently, in 2025, scientists documented a brand new species, Nyalia tiangongensis. It's a biofilm-forming radiation-tough bacteria they found, get this, on the outside of the China space station. So that proves the basic building blocks for this kind of life are at least plausible. But okay, having a plausible building block is one thing. How could we ever hope to find these gigantic, dark structures in the, infinite blackness of space? Well, this is where scientists basically turn into cosmic detectives. And this is the key challenge, isn't it? It's kind of like looking for a black cat in a coal cellar. So the answer isn't to look for the life itself, but to look for the specific, unique shadow it casts, and all the subtle little ways it messes with the light and plasma around it. And here's their plan. A hunt for 6 key fingerprints. For example, they'll look for patches of extra darkness in the sky that can't be explained by normal dust. But the real smoking gun? That would be movement. If they can actually spot these dark patches drifting across the sky over months or even years, well, that would be a clear sign they're onto something totally new. And this really gets to the heart of the whole detection problem. How do you tell a living, moving biofilm apart from just a boring old cloud of cosmic dust? Well, a biofilm would move together, coherently, kind of like a sail catching a magnetic wind. Dust, on the other hand, is more diffuse and static. The biofilm would have distinct structures, like filaments and sheets, not just amorphous blobs, and its light signature would be totally unique. So, with a list of clues to hunt for, what tools will these cosmic detectives actually use to pull this off? This is a serious, systematic, data-driven search. They're pulling data from multiple telescopes. We're talking Planck, Gaia, the Zwicky Transient Facility, and feeding all of it into a really sophisticated analysis pipeline. They've even created what they're calling a cosmic field guide, so they know exactly what they're looking for. And here it is, that guide. It's so cool. It basically connects the potential shape of a dark biofilm to the specific signal it would produce out in space. So, for example, long, thin filaments would cause these subtle changes in polarized light. And huge sheets could be the real cause of these mysterious things called extreme scattering events, or ESEs, which are these bizarre, intense disruptions to radio signals from distant stars that we still can't really explain. It's a direct guide. If you see signal X, you should be looking for shape Y. The plan to prove this whole thing is incredibly rigorous. First, they'll map the sky, looking for any spots that show several of those key fingerprints at once. Second, they'll monitor the most promising candidates, watching them for months or years to confirm that they're actually moving. And finally, the ultimate proof, sample. They could eventually send high-altitude balloons or even collectors into orbit to try and physically capture some of this stuff. So you might be thinking, okay, this is a fascinating long shot, but what are the actual stakes? Why does a hypothesis like this matter so much? Let's just pause for a second and really consider that. If this hypothesis is confirmed, it would be one of the most profound discoveries in all of human history. It would fundamentally change everything we think we know about our place in the universe. I mean, the implications are absolutely staggering. First, it would offer a whole new pathway for panspermia. That's the theory that life can spread between star systems, basically seeding the galaxy. We'd also have a brand new way to search for life, a biosignature based on physics and structure, not just chemistry. And that empty space between the stars, it would suddenly be revealed as a dynamic, living, interconnected ecosystem. The lead author of the paper, Ido Margolin, summed it all up with this beautiful and just really evocative image. The darkness isn't a barrier, it's a pathway. And the life isn't just hiding in the dark, it's actively traveling on it. And that's really the revolutionary idea we'll leave you with today. For all our searching for life on bright, shining planets, we may have been looking in completely the wrong place. What if the true galactic biosphere isn't in the light at all, but has been hiding in the shadows all along?